Okay, guys, basic exponent properties. These are basically the ABCs of algebra. You need them for everything from this point forward, and we've probably already been using them whether you know it or not. Okay, hopefully at this point I will have given you this chart to glue into your journal. If I haven't, then I probably forgot, so please gently remind me. All right, let's go over these exponent rules. We won't use all of them today, but we'll use a few of them, and then we are going to spend several days on using these rules because, like I said, they're very important. They're the ABCs. We can't do many things without them. All right, so the first one is zero exponent. That means anything to the power of zero is 1, whether it's a variable like x to the 0 power or it's a number. 5 to the power of 0 is just 1. We'll talk about why later on. Negative exponents. We don't like to be negative, so if we have x to a negative exponent, what we need to do is do the reciprocal. Since this is technically x over 1, we need to flip that to 1 over x. And now our exponent can be positive. And we all want to be positive. On the next one, product rule, product means multiply, right? If we're multiplying two variables or two constants, for example, like 5 squared times 5 cubed. As long as the bases are the same, we're just going to add those exponents because we're just writing out that number however many times this exponent tells us to. So we might as well just add them up. We'll talk more about that later if that confuses you. If you have any questions as you're watching this video, please write them down and ask me when you come to class. I would be so happy to answer some legitimate questions other than I just don't get this at all. Quotient rule. Quotient means dividing. If we're dividing and the bases are the same, then we're going to subtract from top to bottom. So I have here the example, the bases are the same, so I'm just going to do m minus n, and we'll look at some examples in a minute. Power to power, we're not going to get to this today, but anything raised to a power is multiplying. Notice the parentheses here, that's important. Product to power rule, that's just saying if there is some exponent outside the parentheses, everything inside the parentheses has to be raised to that power. X has to be raised to that power, y has to be raised to that power, and if we had a constant like 5, it would also have to be raised to that power. And the quotient to power rule, this is multiple things going on here. Even if we're dividing on the inside of our parentheses, if we have an exponent here, again, everything on the inside will have to be raised to that power. All right, let's go on to some examples. Simplify 2x to the 5th power times 5x to the 4th power. Group powers with the same bases. What does that mean? That means that they have to have the same variable as their base. Here we have x to the 5th and x to the 4th. So we're going to regroup those so that like things are together. 2 times 5, those are our two constants. And then we have our two variables with the exponents. So product of powers property says that we just need to add those exponents, 5 plus 4. And of course, 2 times 5 was 10. So our answer in simplest form is 10 times x to the 9th power. Not that difficult, right? At least not yet. All right, the next example, when we're dividing. So this is going to use the quotient rule. Again, we're going to do the same first step. Just group our like terms. I'm going to go ahead and write this as 2 over 1 because sometimes there might be another number down here, and we need to remember that if there was, we have to simplify it. So we have x to the 5th, and this x doesn't have an exponent, so that just means it's an exponent of 1. So we're going to have x to the 5th divided by x to the 1st, and then y to the 4th divided by y to the 2nd power. quotient of power property says that we have to subtract from top to bottom when the bases are the same. So 5 minus 1 and 4 minus 2. That's what we're doing right here. Now we're going to simplify the exponents. 5 minus 1 is 4, and 4 minus 2 is 2. So this is our answer in simplest form. And now let's look at some other examples. And let me see here. I know technically you can go ahead and fast forward the video or whatever and see what the correct answers are, but I really want you to pause the video right here. Well, let me move it down so you can see. Pause the video right here and simplify each one of these expressions. All right, let's pretend that you did that. So let me take this away and now let's go over them, see what you got right. And you didn't have to work out the problems totally, even if you just got part of it correct. That's progress. All right, this first one, we need to rearrange our terms. So we have 4 and negative 2. Those are our constants. Let's put our variables together that are alike. We have x to the first in this parentheses and x squared here. So we're going to be adding those exponents since we're multiplying with the same bases. And y to the fourth and y to the fifth. We're going to be adding those exponents. So now let's simplify. 4 times negative 2 is negative 8. 1 plus 2 gives us x to the third. 4 plus 5 gives us y to the ninth. Let's move on to the next one. We have 2 over 4. Those are our constants. Then we have a squared over a to the first. That's in the denominator. B to the fifth divided by b squared. Then we have a c in the numerator, so that's c to the first, and 1 in the denominator. So now let's begin simplifying. 2 over 4 is 1/2. We're going to subtract top to bottom. So 2 minus 1, 5 minus 2, and 1 minus 1. Now let's simplify that even more. We'll get back to this one in a second. So 2 minus 1 was a to the first. 5 minus 2 was b to the third. And 1 minus 1 is c to the power of 0. Remember, anything to the power of 0 just goes ahead and becomes 1. So we don't need that 1 since any number times 1 is itself. So we're going to cross that one out and cross that one out. And this is our answer in simplest form. And the last one, 6 over 18. And then we have, let's write this over 1, 2 over 1. So we'll multiply, we'll get 12, 6 times 2 over 18, simplifies to 2/3. Now we have y cubed and y to the first, which came from right here. And we have x in this denominator, and we have x up here in the numerator. That's why it's so important to write this as a fraction, so we can see that 1 is in the top, 1 is in the bottom, which means that we're going to have to subtract those. So let's add the exponents for y, since those are multiplying. And we're going to subtract the exponents for x, since they are dividing. So we already got that was 2/3. 3 plus 1 gives us y to the fourth. And then this becomes x to the 0 power, which is 1. Womp womp. So that means we don't need that one. And this is our answer in simplest form. Thanks for watching. And again, please make sure to bring any questions that you have so we can answer those at the beginning of class, and make sure that you are ready for the class assignment.